Up until this point, we've been dealing with the popular slope-intercept, or y equals mx plus b format. Why? Mostly because it's easy to graph. But students should be aware of the standard form linear equation ax plus by equals c, where in this case a, b, and c are the constants, kind of like m and b are the constants in the slope-intercept form. They represent numerical coefficients and or constants. Alternatively, there's a point-slope form of an equation. That basically just takes the slope formula, m equals y2 minus y1 divided by x2 minus x1, and makes the x2, y2 a variable that you can change over the course of the line. The result is you get a linear equation. These all can represent the same line. However, point slope, we generally can do everything we need to do here with our slope-intercept form, and students probably find it more intuitive to work with y equals mx plus b, so we will not spend time on that. However, we will focus today on our standard form in this particular lesson. Why? Because it's critical for the exam. You're going to see a lot of it. And students generally, they really don't understand it as well as they should. So first things first, I want to be able to convert back and forth from slope-intercept to standard form. I want to solve essentially my equation. So let's suppose I had 5x plus 10y equals 20. How might I put that into y equals mx plus b format? Perhaps I want to know what the y-intercept is. Well, notice in standard form, you don't get a y-intercept right off the bat. I want to know the slope. Well, again, in standard form, notice you don't see the slope directly, so I might solve for y in this case, and many students will do that on the exam. So how would I do that? Well, algebraically, I'm going to subtract 5x from both sides. I'll get 10y equals minus 5x plus 20. I'll divide through by 10 on both sides and end up getting y equals minus 1/2 x plus 2. Now I know how to interpret that, or most students would say they do. The slope is negative 1/2. It's going to be relatively flat, downward to the right on my graph, and it's going to intercept the y-axis at plus 2. So we can interpret that and understand that from our previous work. But how do we interpret and understand everything we can, or a lot more than we do, directly from standard form? Can I look at a standard form equation and easily graph it, determine the slope, find the y-intercept, figure out what a parallel and a perpendicular line is between two standard form equations? Well, the answer is yes. Let's first talk about graphing. Suppose we took the equation up above, 5x plus 10y equals 20, and I want to graph it. Well, again, I don't have a y-intercept and a slope, so I'm not piecing it together the way I did with the slope-intercept form, but I can graph it by looking at the x-y intercepts and connecting points. For example, the x-intercept must occur at y equals 0. The equation of the x-axis is y equals 0. So I can solve the equation, the standard form linear equation, when y equals 0. That's 5x plus 10 times 0 equals 20. Divide through by 5, x equals 20 over 5, x equals 4. So I know my line intersects the x-axis at 4. If I want the y-intercept, I always plug in x equals 0. And by the way, these concepts are true no matter what type of function you're looking at. Doesn't have to be linear. It could be quadratics. It could be cubics. Could be, trigonometric functions. You name it. Okay. I'm going to plug in x equals 0 for my y-intercept. So 5 times x is 0 plus 10 times y equals 20. And that means 10y equals 20. Y equals 2 when x equals 0. That means my y-intercept is at 2 right here. I can connect those points, and that's the graph of my line. I know how to graph from standard form. In this case, I'm just finding the x-intercepts and the y-intercepts of the graph and connecting them. And by the way, if you look, you'll notice that's a negative 1/2 slope downward to the right, as we knew from y equals mx plus b format when we solved it, and it has a y-intercept of 2. This is consistent with our slope-intercept form. Okay, great. I know how to graph a standard form. How do I quickly determine the slope? Well, one easy way to sort of identify whether your slope is positive or negative is if they have the same signs for the coefficients of x, plus 5 and plus 10, then your slope is negative. It's downward to the right. If they were minus 5, minus 10, again, the same signs, positive and negative for the coefficients, it's a negative slope. If they were alternate signs, say 5x minus 10y equals some number, 20, we know they have a positive slope. So different signs, plus, minus, or minus, plus, the slope is positive. So I can immediately look at a standard form linear equation and tell you if the slope is positive or negative. Okay? How about figuring out the y-intercept? Well, we actually just did that by plugging in x equals 0. Notice that's true for any function we plug in x equals 0. How do we figure out if lines are parallel or perpendicular given a standard format? Well, it helps to convert that standard format into y equals mx plus b format. We can see the equivalent of m is minus a over b. So it's the ratio of the coefficients of x and y that determine the slope. And we can see c over b represents our little b, which is our y-intercept. So c is not directly the y-intercept, but it is only impacted or affected by the intercept. In other words, it shifts the line up and down, does not change the slope. The ratio of the x and y coefficients a and b, that changes the slope. So if I looked at, let's again go back to say 5x plus 10y equals 20. The ratio of the x to y is 5 to 10. So if I want to find a parallel line, I must have that same ratio. Say 2x plus 4y equals some constant. That line is going to be parallel. Why? Because the ratio of the x to y coefficients is 2 to 4, which equals 5 to 10. It's 1/2. It's the same ratio. So I can quickly check the ratios of the coefficients to determine if lines are parallel. Likewise, in standard format, if lines are perpendicular, they're going to have the opposite and switch the coefficients. Well, what does that mean particularly? Let's start with 5x plus 10y again equals 20. A perpendicular line would be 10x minus 5y equals 20. You will switch the xy coefficients, or at least proportionally, and one you'll change sign of them. The other one you'll not. This is a perpendicular line in standard form to my 5x plus 10y equals 20. Okay? How could I create a different one? Let's say I've got minus 2x plus 3y equals 5. Again, I'm going to switch them around, the coefficients, and change one of the signs. So that could be 3x plus, it's changing the negative to a positive, plus 2y, switching the coefficients, and then I don't have to adjust the actual c unless I need to figure out a particular point it passes through. This line is perpendicular to the original line. Well, let's just double check that. Can we see that actually in slope-intercept form, which might be more intuitive? Well, if I solve the first line for y, I would get y equals 2/3 x plus 5/3. So I have a slope of 2/3 on my original line. Let's solve y for the perpendicular standard format line, this one here. Well, in this case, subtract 3x from both sides. Y equals minus 3x, and I'm going to divide by the coefficient of y. So minus 3/2 x plus 5/2. I have a negative reciprocal coefficient. So you can see this process does work. They are perpendicular lines. All I'm doing for perpendicular is switching the coefficients, or at least the same ratio of coefficients from x to y and vice versa, and changing the sign of one of them. So that might sound a little tricky, but it's actually pretty quick and helps you determine from standard form whether you have perpendicular lines. So now I can graph a standard form. I can quickly assess the positive and negative slope of a standard form. And I can tell you whether standard form lines pretty quickly are parallel or perpendicular, and I can quickly assess the answer choice and figure out which is which can be very useful on the exam. It helps to gain a greater appreciation of standard form linear equations. As we go to solve systems of equations, that's going to become the norm even more than slope-intercept.